Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to discuss first significant figures. This is our first topic. In the last lecture, we discussed the SI system of units. Then we discussed fundamental units and derived units. Now, what is a significant figure? You need to remember, if a numerical value is expressed in standard notation or scientific notation, which we discussed in last lecture, then the number of digits in the decimal number is the number of significant figures in the numerical value. Repeat, if a numerical value is expressed in standard notation or scientific notation, the number of digits in the decimal number is the number of significant figures of the numerical value. And remember, in scientific notation, what we do, we express a numerical value as a product of a number between 1 and 10 and a power of 10. For example, the mean radius of the Earth, the mean radius of the Earth is 636 1 2 3 4 zeros, this much meters. 636,000,000 meters. So when we express this mean radius, this numeric value in standard notation or scientific notation, in standard notation, this becomes what? This becomes 6.36 into 10 raised power 6 meters. 6.36 into 10 raised power 6 meters. Now this is my decimal number. Number of digits in this is 3. So it has 3 significant figures, right? So it is simple. If we are given a numerical value, we express it in standard or scientific notation. Then we see the number of digits in the decimal number. That is the number of significant figures in the given numerical value, right? Another example, let me name it example 1. Another example, we have already discussed this example in last lecture. The wavelength of yellow light from a sodium lamp is 0.0000059 meters. So when we write this in standard notation, there is 5.9 into 10 raised power minus 7 meter. 0.0000059 meter. So in scientific notation, I move this decimal point here through 7 places. So it becomes 5.9 into 10 raised power minus 7 meter. So you can see the number of digits in the decimal number is 2. Therefore, it has 2 significant figures, right? So I hope you got the idea of significant figures. Now, calculators give numerical answers to as many significant figures as there are digits on the display. This can be misleading since the answer to a calculation should always be to the same number of significant figures as the data supplied. Most data for problem solving exercises are usually given to no more than 3 significant figures. A numerical answer should therefore be rounded up or rounded down to match the number of significant figures of the data supplied. The general rule, to write it, the general rule to is to round up if the last digit is 5 or more. Round down otherwise. For example, if we have a value of 6.36 and we want to round it to two significant figures, we write it 6.4. Try to understand it. I'm saying the general rule for rounding is to round up if the last digit is 5 or more and round down otherwise. So if I have 6.36 and I want to round it to two significant figures, so I have to drop this 6, but I have to round up this 3. That means I have to add 1 to 3, so I write it 6.4 because the number which I want to drop is more than 5. So when the number to be dropped is 5 or more, you round up. That means you add 1 to preceding digit. So 6.36 rounded to two significant figures is 6.4. Similarly, if I have a value of 6.33, it would be rounded to two significant figures as 6.3 because the number which we are going to drop is less than 3, so we round down it. That means we throw this 3 and don't change the preceding digit, right? We only increase the preceding digit by 1, that is round up. When the digit to be dropped, that is the last digit, is 5 or more, as in this case. This is how we round these values. These are rules for rounding. The next idea which we are going to discuss is symbols and equations in physics. You know, physical quantities are usually represented by a standard symbol. For example, time is usually expressed by symbol T. Similarly, we use Greek symbols sometimes. For example, Greek letter written read as rho is used for density, right? The symbol represents a numerical value and its unit. Equations and formulae in physics are usually presented in symbolic form. For example, the word equation density is equal to mass or volume can be written as rho is equal to m over v. Rho represents density, m represents mass, and v represents volume. You can see from this equation rho equal to m over v that the SI unit of density is kilogram per cubic meter, right? Now, when you have to use an equation, what we do in physics, we write down the equation and the values of the known quantities, rearrange the equation so the unknown quantity is the subject of the equation, substitute the known values into the rearranged equation. In simple equations, include the units, then calculate the unknown quantity and write down its numerical value and unit. So let us do examples. Let me call it example 1. Calculate the mass of a steel block of volume 0.15 cubic meter and density 7,900 kilogram per cubic meter. So let us move to the solution. Very easy. We have to calculate the mass of a steel block whose volume is given as 0.15 cubic meter and density 7,900 kg per cubic meter. You can see density is mass over volume. Volume is given 0.15 cubic meter. Density rho is given 7,900 kilogram per cubic meter. When we rearrange the equation rho equals to m by v, we get m is rho times v. Put the numbers 7,900 kg per cubic meter multiplied by the volume to 0.15 cubic meter, or cubic meter, it's okay. When we do it, it turns out to be 1185 kilogram. This cubic meter cancels with this cubic meter inverse. We get our answer in kilograms. Always check the calculation at home. This is how we rearrange equation and solve for our unknown. Let us do another example. Example 2. It goes like this. The area A of a circle of diameter D is given by the formula A equals pi D square by 4. Calculate the diameter of the circular plate of area 0.10 meters square. So let us move to the solution. Let me check the question. The area A of a circle of diameter D is given by the formula A is equal to pi D square by 4. Calculate the diameter of the circular plate of area 0.10 meters square. So when we rearrange this equation for area, we solve for D square as 4A by pi. So let us put the numbers. 4A is given 0.10 meter square. We have pi. Downstairs, when we solve it, it turns out to be 0.127 meter square. Hence, what is D? D is square root of 0.127 meter square, which turns out to be 0.36 meter, right? This is our answer. We first solve for D square as 0.127 meter square. Then D turns out to be square root of this number. When we solve it, it is 0.36 meter to two significant figures, right? Check the calculation. So these two examples illustrated the idea of rearranging the equation and solving for the unknown. Now I will give you some homework. The homework goes like this. Write the following values in standard form to 3 significant figures. Part A is 150 million kilometers in meters. Part B, 365 days in seconds. C, 630 nanometers in meters. D, 25.78 micrograms in kilograms. Part E, 1502 meters in millimeters. F, 1.245 micrometers in meters. This is your homework. Let me check it. Write the following values in standard form to 3 significant figures. Part A is 150 million kilometers in meters. Part B is 365 days in seconds. Part C is 630 nanometers in meters. Part D is 25.78 micrograms in kilograms. E is 1502 meters in millimeters. F is 1.245 micrometers in meters. This is all for today. I hope you are enjoying the lectures. Don't forget to like, share, and subscribe my channel. You can give comment in the comment box. Thank you. God bless you. Assalamu alaikum.